Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Hi, and welcome to my course Linux Bash Shell Scripting through real life examples. This is a course where I will actually hold your hand and walk you through the real life scripting language where I have learned not from the books, I actually have learned through experience how we created the script. And that's how I'm going to show you in this class. This class is for the people who actually are already in Linux and are comfortable with Linux command line, who know how to do somewhat of file editing, and now they want to improve their skills in Linux shell scripting. I'll take you from basic shell scripting to advanced level shell scripting. So this is about my course. Now, let me tell you about myself. My name is Imran Afzal, and I've been in IT for over 16 years. And I've been working in Linux operating system, Windows, VMware, teaching, documentation, project management, you name it. I have a bachelor's degree in computer information system from Baruch College, City University of New York. And then after that, I did my MBA from New York Institute of Technology. So once you take my course, I will tell you this much, that at the end of this course, you will learn so much about shell scripting that you could just go out there and automate your daily, regular, tedious tasks. So are you ready to take this journey with me?
Hi everyone, let's go over our syllabus. What exactly are we going to cover in this class? I have actually divided my class into 5 different sections. Section 1, which is the lab setup. In this section, we will cover what is a virtual machine, how does it work, downloading and installing a virtual box, creating first virtual machine, and doing the Linux installation. Now please remember this section is for those who actually have never installed or who do want to install a lab Linux machine in their laptop or their workstation. If you already have a Linux machine and you want to start practicing your Linux scripting skills from this course, then you could simply skip through this entire section and go right into section 2. In section 2, we'll start off with shell scripting basics and what those basics are, starting with kernel, how kernel interacts with shell. What is a shell? Shell scripting, how does shell scripting come along? How can we take advantage of it? What are the different type of shells? Of course, there are tons of different shells: Z shell, K shell, C shell, Bash shell. What is our focus in this class? And of course, our focus is Bash scripting, but I will cover other shells as well. Starting a shell, how to run a shell script. Then moving on to section 3. We have in section 3, we will cover the scripting standards. What exactly the standards that you should follow when you are writing a shell script. And those are how to name your shell script. So this way you will have a proper naming convention for your shells. Script file permissions. So when you create a script, you would need a specific executable permissions and what those permissions are and how can we assign them. Then shell scripting format, what goes inside of a script, what are the comments, what is, where do you define the shell, what are the variables, the sequence of shell script. Then moving on to the section 4, which is where we're going to start off with actual writing scripts, the basic shell scripts. And I'm not going to overload you on this section with like huge scripts. So I'm going to take baby steps with you as if you are starting fresh with me in Linux shell scripting. Then I'll show you how to create your first script. Script to run basic tasks, and those tasks are system administrative tasks. Defining variables, input, output scripts, conditional scripts, if else statement scripts. We'll cover the case statement scripts. We'll cover for loop scripts. We'll write it. I'll give you the examples. We'll create do while scripts. How do they work? What are the exit status? How can we use the exit status in shell scripting and make use of it? And then we have a bunch of handouts that you could read on shell scripting that would help you write more script and understand scripting details, scripting basics as well. Moving on to the section 5, which is our biggest section, and you should be ready for this section. By the time you come to this, you would know exactly how to start, how to get your hands dirty, and you are already on a driving seat at this point. This is where we will cover the real life scripting examples, and some of them are accessing data from files, check remote server connectivity, script for scheduling and notification, script to delete all files, backup file systems when you want to back up your system when you don't have a third party backup tool, how you could use a scripting language to do that, for loop scripts for file system. That is for one of the section, and I have not included just one for loop. This lesson, this specific lesson would have like four or five for loop scripts that I have covered in this one section, sorry, in this one lesson. Then for loop script for file system 2. Now this is another lesson. Now I have split that entire lesson into two lessons. Why? Because I'm covering like 5 to 8 different scripts. Moving on, copy files to a remote host. User directory assignment. You will see how we could check if a directory exists and it doesn't belong to the user. This is a security risk. How we could put a script around it. Real life examples. Again, moving on to section 5. Section 5 is not finished yet. List of users logged in by date. Central logging script. If you do not have Splunk, which is a logging third-party tool in your environment, it's okay. We'll create our own Splunk, our own logging syslog script that will run like a Splunk. Collect your logs. Script for user account management. Disable inactive users. That's a script we'll cover. Check process status and killing it. Status and total number of files, scripts to create system inventory, getting online help, homework, and there's going to be so much many other scripts that I cannot just add everything here in this syllabus that I will be keep adding it later on. So this is what we actually going to cover in this entire course. So are you ready with me? Are you ready to go ahead and start? Let's go. All right, guys, welcome to the lab setup. In this section, we are going to actually set up our lab where we will be practicing our scripting skills. We will be building our Linux machine and we will be creating shell scripts. So let's see what exactly are we going to do in this lab setup. So this is a quick step-by-step instruction of what we're going to be doing following this lesson. In this section, I will be covering about the virtual environment. This is for those who actually don't know what virtual environment is or what a virtual machine is. So I will be going over some of the fundamentals of virtual environment, how it works. Then what is Oracle VirtualBox? So of course, in virtual environment, there are so many virtual products that are out there. There's VMware, there's Oracle VirtualBox, there's Microsoft Virtual Environment. So which one to pick? So in our lab setup, we will be installing Oracle VirtualBox, and that's where we will be setting up our Linux lab environment. So after that, we will be installing Oracle VirtualBox on it. Then it's a complete process. I have actually including every single thing in this setup. So where do you need to get the download file? How do you have to install it? How do you have to configure it? And then we will cover the first virtual machine. So once you have the Oracle box running, then what do you need to do with it? You need to create a virtual machine. What is a virtual machine if you don't know? Then I have covered that in this section. You don't have to worry about a thing. I will walk you through step by step and every all the way through on setting up your Linux machine. And then once you have the Linux machine up and ready, then we will do the Linux installation. And the Linux installation I will be covering is the CentOS, which is exactly like Red Hat Linux, which is used mostly in the Linux environment, in a corporate environment. So this section covers all about setting up your lab. Now, let me tell you this. If you already have a lab or if you already have a Linux machine, then you do not have to do this entire section. You could simply skip through it. You could start up your own Linux machine that you have. It's either Ubuntu, it's either CentOS or Red Hat. I would prefer that you go with CentOS and Red Hat because most of the scripting languages and the shell scripts that I will be using in Bash language. If your Linux operating system understands the Bash programming language, that is fine. You could use that. If you wanted to install Linux from scratch on your physical machine, you could also go. You are more than welcome to do that. But if you do not have any Linux machine, then this section is really going to help you. And once again, if you do have a Linux machine, not to worry about it, just go straight to the next section.
What is Oracle VirtualBox? And of course, why do we need to know about VirtualBox? Well, for this course, you do need to install CentOS Linux operating system on your computer, and there are two ways you could install it. One, you could remove the existing operating system that you have on your computer, or you could install VirtualBox on top of your existing Windows operating system or Mac, and then you could install CentOS, so you this way you won't lose anything. So basically, VirtualBox is a free and open source hypervisor for x86 computers currently being developed by Oracle Corporation. It installs on your existing Intel or AMD based computers, whether they are running Windows, Mac, Linux, or Solaris. It extends the capabilities of your existing computer so that it can run multiple operating systems on one hardware at the same time. Let's see how it works. So you have when the hardware layer, and then on top of it you install the operating system. Of course, it could be any one you have that is Windows or Mac, and then you install Oracle VirtualBox. It's just a program, a software that you install on your machine like any other software that you would install. Once you have installed Oracle VirtualBox, then you could install Linux on it as a separate small version of operating system. You could have Windows on it, or you could have Mac on it. So this VirtualBox allows you to have multiple operating system on a same hardware. In this lecture, we are going to cover the Oracle VirtualBox. We will go through the download and the installation of VirtualBox. Now, as I said previously, the Oracle VirtualBox is is a virtual environment which allows you to run a multiple operating system on the same hardware. There are other virtual platform that is available out there that you could use. You don't have to go with VirtualBox if you don't like it. You could use VMware Player Workstation, as well as other open source virtual environment. But anyway, I would prefer if you stick with Oracle VirtualBox, so this way we could go through the course together. Alright, so I will go open up my Firefox browser so I could download the VirtualBox software. You could use any browser you like. Then I'm going to the Google page, and in the Google page, I'm searching for Oracle VirtualBox. When you click on it, you're going to see the first link as Oracle VM VirtualBox. So you could click on it and then go to download, or you could go straight to the download page. Alright, on the download page, you're going to see the section where it says VirtualBox version platform packages. Now, depending on when you are downloading this VirtualBox, the version will be higher, maybe 1, 2, or whichever the version at that time you're downloading. It doesn't matter. Don't be confused. Oh, the one I am showing you is 6.0, and the one you are seeing is a different version. Basically, what we want at the end is a virtual platform that we could run our guest instances or guest operating system on it. Anyway, if you are using the Windows as your main host, wherever you will run the Linux CentOS as a VM, then pick Windows host. If you are using OS X host, meaning if you are using Apple, then you could use this one. For Linux, for Solaris, for other operating systems, you could pick depending on your requirement of your actual operating system. Go ahead and click on Windows host because I am running Windows host, and that's where I'm going to run my VirtualBox. Now here it is asking me to save the file, and you could click, but I'm not going to click to save the file because I have already saved it to save some time. So if you have not saved it previously, so go ahead and click on this, and it will ask you to the location to save it. So I'm going to cancel it since, as I said, I have already saved it. Alright, I have my VirtualBox executable saved on my desktop, and here is the executable. All I have to do is go ahead and double click so it could start the installation. So once you double click on it, it will ask you, do you want to run this file? Click on run. Okay, now the wizard has started. It says welcome to the Oracle VM VirtualBox 6.0.14 setup wizard. The setup wizard will install Oracle VM VirtualBox on your computer. Click next to continue or cancel to exit the setup wizard. Go ahead and click next. Select the way you want features to be installed. So by default, the VirtualBox application has been selected, and the other features that comes with it, I'm going to leave everything at default. And it also tells you the version installing the feature requires 227 megabyte that you should have on your disk. So go ahead and click next. Please choose from the options below. Create start menu entry, create a shortcut on desktop, create a shortcut on quick launch bar, register file association. I like them all, leave them default, except I don't like create a shortcut in quick launch bar. So I'm going to uncheck it. Again, that's my preference. You could leave all of them selected. Click next. Network warning, network interface. Installing the Oracle VM VirtualBox networking feature will reset your network connection and temporarily disconnect you from the network. Proceed with installation. So that's fine. So make sure you are not connected to the internet, or if you are, make sure you're not doing any type of work that you will lose. So go ahead and click yes, and click install to begin the installation. Install. I am going to fast forward at this part because I don't want you to wait. I don't want to waste your time. So I'm going to just simply fast forward. Okay, so the Oracle VM VirtualBox installation is complete. You can leave the check mark so it'll start it back up, and you could click on Finish. Congratulations, you have completed the download and the installation of Oracle VirtualBox. Now the next step is to create a test virtual machine, and then of course we will go ahead and do the actual operating system install on that virtual machine. Hello everyone, in this lecture we are going to create a virtual machine on our VirtualBox, the VirtualBox application that we have downloaded in the previous lecture, and now I'm going to show you how you could create a virtual machine. So I'm going to start up the VirtualBox. This is what I have it open already, and the version that I'm using for the VirtualBox is, when you go to help and click on about VirtualBox, is VirtualBox 6.0.
If you're using a little later version or updated version, that is perfectly fine. Every version would just work fine. Now, as an example, as a test, we are going to create a new virtual machine. So I want you to go ahead and click on a new. And here I want you to type, um, for example, my Linux VM. So now as you type this, it's going to tell you where it's going to save the information of the Linux machine. So it picked up this location by default. Next one, it says the type. The type is Linux, of course, because I have typed the name, it automatically picked it up that it's assuming there's a Linux machine, and the version is Linux 2.634, or whichever version, and it says 64-bit. Now, if your computer right now or your virtual machine setting is showing 32-bit, which is this, and you do have a 64-bit operating system, then what you need to do is you need to enable virtualization technology in your BIOS setting. So again, if it is showing 32-bit, then first thing you need to confirm is that your computer that where you're running this virtual box actually is 64. So I could confirm by going into my computer. I could go into my computer right here, right click on it, go to properties, and in my computer properties, you're going to see that I have a system type as 64-bit operating system. So if this is your system type is showing right now 64-bit operating system, and you're still seeing this version showing up as 32-bit, then it means that you have to go into your computer BIOS setting to enable virtualization. And how to do that, I have included an article in this lecture, in the description, that will make you go through how you could enable that. Anyway, so once you have it enabled, good, reboot your machine and it will show up as 64-bit. Now the next thing is you need to define the memory. Memory is the memory of your virtual machine. It's just like if you are going to a store, right? Let's say if you're going to Best Buy or any computer store, and you pick up the laptop and or computer and you ask how much memory it has. This is exact same way that you are doing, but the difference is that now you are the manufacturer. You are the one who is putting in the memory inside of your computer. By default, I'm going to leave it as 1024 megabyte, which is 1 gig. The next part is hard disk. Create a virtual hard disk now. Leave that as default and click on create. Then it says the file size here is 8 gig by default. It's picking it up. I want you to pick 10 gig just to make sure we have enough space when we are going through all the exercises of our training. All right, so then hard disk file type is VDI, virtual box disk image, which is by default is the right file type. So leave that as is. Storage on physical hard disk, dynamically allocated. Leave that as default as well. If you need to know more about it, what's the difference between each one of them, I'm sure you could go and click on guided mode, or you could also look it up online on the difference of each of these hard disk type. Go ahead and click create. And now you're going to see right here, it's going to show you my Linux VM and its configuration or specification of that VM. The general information showing up here, the system information is up here, the displayed storage, audio, network, USB, shared folders, all that. It is just like as if you have an actual machine. So anyway, you have created your virtual machine. This is the lecture I wanted to go through, how you could create a virtual machine. When I am going to go through the next lecture where we will do the actual CentOS or Linux installation, then I will ask you to create the virtual machine again. So for this lab purposes, you just go ahead, click on the machine, then right click and click on remove, and then just click on delete all files. Beautiful. All right, so that was just an exercise. Let's move on. Welcome to the new section of shell scripting basics. That's where we actually will learn what really a shell scripting is, what are its basics, like starting from ABC or 1, 2, 3. So that's where we're going to start. So let's see what exactly are we going to cover in this entire section. So we will start with kernel, what exactly kernel is and how does it interacts with the shell. And is there a kernel in operating system and how does it interacts with your hardware and how does it interacts with your shell and your operating system? What exactly shell is, of course, this is the main thing we wanted to know. How the shell scripting works. There are so many types of shells. There are corn shell, there are bash, there are C shell, and so many that I will cover in this lesson. Then we will have starting a shell. How are you going to start a shell? If you are logged into your Linux machine and by default you have a bash shell and you want to switch to a different shell, how do you do that? Then we'll cover how you could run a shell script. So you have created a script. Now, how do you run it? So this is a few things, very basic ones that you should really know, and this is like a fundamental things that you should understand and put it somewhere, deep in your head that outside of these are like actual guidelines that you have to follow in order to run a perfect shell script. So you would know when if there is an error message or if there's a problem when you're running a shell script, why did it happen? This section will explain you if you really go through it. Shell. What is a shell? In this lesson, we'll cover about the shell, how the shell works, and how you can run commands within the shell or how the environment is set up in a shell. So, what exactly is a shell? Shell is like a container, like you have like a Tupperware in your home or any kind of containers that holds your environment, your information inside of it. It's interfaces between users and kernels or operating systems. So you have built an operating system, and then it is provided a platform you to execute commands. Again, Windows is one of the platform in Windows operating system. When you start up a GUI, you execute commands by double clicking on a program. So that GUI interface is your shell. In Linux, when you don't have a GUI, you are given a terminal shell or CLI command. That is your shell. To find your shell, you could run a command like echo dollar and zero that will tell you what shell you are in. And you could also get a listing of all your shells in your Linux distribution by running the command cat etc shells. Your shell is also inside of etc password that is defined inside of the file. In Windows, GUI is a shell. In Linux, KDE GUI is a shell. In Linux, SH, which is shell, bash, etc. All these are the shell that is provided to a user. Again, we're looking at this diagram again, and we are second from the top. You'll see the application that talks to the shell, and then shell talks to kernel, and kernel is the one that is telling hardware what to do. Let's look at our Linux machine and we'll see how we could find our shell. We'll open up a terminal real quick. And when you do echo $0, it tells you you are in bash. So you could look at the available shell that is installed in your distribution by doing cat etc shells, and it tells you all the shells that are available. And when you look at an etc password, cat etc password, and you'll see in my username, which is right here, it tells the shell is all the way at the end that I have a defined shell which is bin bash. I could change that shell if I want to a different shell, but I try to keep it consistent with other users. So that's what the shell does, and we'll cover in the later lessons how we could talk to shell to create scripts and other things to automate our tasks. So now let's talk about what is a shell script. So put all your instruction in a shell or in a container and just run it. So if I have to explain it through a diagram, let's put it this way. This is a shell, right? Like actual a shell. So you actually putting all those things, all those instructions, like do this, do that, or else do that, etc. Everything you putting that together in a shell and then telling shell run this set of instructions and of course run them in a sequence. By default, the shell runs all the instructions in sequence. Now, if you notice, you go to Windows and you want to copy a file from one folder to another. You right click to it or control C to it, and then you go to another window and then you paste it. Now, how does it work? How does Windows knows that I have been given instructions to copy it and paste it? Because when you right click, it gives you the option to copy. And when you go to another window, it gives you the instruction to paste. That is the function of a shell. The shell is a copy, instructions to copy. A shell is instruction to paste. So just like that, any of the commands or any of those functions that you run in Windows, they are all created within a shell, within a commands. You don't see those commands. In fact, if you wanted to really run in Windows, you could just go to open up the DOS prompt and you could actually run those commands, the copy command to copy file from another. But of course, Windows Microsoft had made your life a lot easier to run all those commands through graphical interface, which is click, click, click. Now in Linux, you don't have that luxury, and that's why also Linux is different, is because it's not GUI based kind of um, operating system. It's a command line, so you could run your function a lot faster, so you don't have to deal with GUI and GUI using up your CPU and memory. So what do? You run a copy command, or you run move command, or all those commands that you run. Those are, what are those? Those are actual the scripts. Those are shell scripts. And who have written those? The developers. Those people who have done development, those people who do C++ plus plus or C development, they create those scripts. So you could use those scripts, leverage on those scripts, and create your own shell scripts. So that's how the shell scripting works.
Linux kernel. Do you know there is a kernel in every Linux distribution or Unix distribution? What exactly a kernel is? It actually interfaces between your hardware and your software. So let's look at this diagram. Here you will see you have at the bottom is the hardware. And what are those hardware? Hardware is like CPU, memory, hard disk, and any outside hardware peripheral devices. Then you have kernel. A kernel is a program that is stored inside of your operating system. It's like a program, a command that keeps on running. And what it does is it takes the commands from shell. And shell, what is a shell? Shell is anything like a GUI that we have in Windows or a GUI in Linux. Or if you don't have GUI in Linux, we have terminal that runs bash shell or C shell, which we'll cover later on. So when we are in that bash or C shell terminal environment, we execute commands. The commands are being forwarded to kernel, and it's kernel's responsibility to talk to the hardware that's inside of your computer. And then you, on top of that, you have a browser, send mail, all the applications that we run, like calculator, calendar, office, or any Linux related applications. And of course, on top of that are the users, and that is you. So shell and kernel together, that software built together in one package, and that is called operating system. And that operating system is any operating system like Linux, Unix, Mac, or Windows. Every operating system has that little program that actually talks to your hardware. And anything that is a shell, which is written in C programming language as well, that shell or that
those applications are actually the software. So this is what the real kernel means, and we really need a kernel in any operating system to talk to our hardware. One of the basic things that we should know is how to run a shell script. So when you create it, there are different ways you could run it. You could run it through absolute path, or there's another one that's called relative path. So absolute path is if, let's suppose, if you are standing right at the first step of a stairs and you have to pick up something on the very last stair on the top, you have to actually either shoot from the first stair all the way to the last stair on top and grab that thing that you're trying to grab, or there's another one, another way is relative path. The relative path is that you actually walk up to the stair and then grab that thing that you wanted to grab. It's the same way um, absolute path and relative path works. If you do not know what exactly absolute path and relative paths are, I would recommend you that you should, try to look it up online and see what they are and how they work. And you'll find a tons of article there. And make sure you type absolute path in Linux or absolute path in relative path in Linux as well. So the way it works is I have my Linux machine up. Let me log into my Linux machine. So I have my script right here. It's called xyz-script. If you notice, I am in my slash home slash ifzol and slash script directory. I created a directory called scripts in my home directory, and I create all my scripts in that directory. So if I am already in that directory, I could run that script. Or if I'm not in my directory, let's say if I just do cd, and which directory I'm in slash root. So the script that I want to run, it's just a test script that I created earlier. Let's say if you type that script name xyz dash script, and when you hit enter, you'll see it says bash the script name command not found. Why? Because the Linux operating system is trying to find that script in slash root directory, and I do not have that script in slash root directory. So I would have to specify the absolute path to run the script, and the absolute path would be just the same way as if you are standing at the bottom of the stairs and then you have to fetch something from the top of the stairs, then you actually through some kind of means or like a stick or something, then you could grab it. So the same way you could specify the entire path, which is slash home, my user directory, scripts, and now the name of the script. Now when I run the script, I'll hit enter and you will see it's just a script that is actually echo out or print hello world on the screen. How does this script create it? I will cover that in later lectures, but just to focus, this is how you need to run a script using absolute path. Now, what if you are in a relative path, which is that you are already in home, ifzol, and scripts directory? See, you cd into that directory, you do pwd, and you'll see the path is the complete path now. Now, the script name is, again, when you do ls-ltr, I have that script xyz script. Now, when you run the script now, script, and hit enter, it still cannot find it. Why? Because when you are inside of a directory, you will always have to specify that you want to run the script within this same directory, and that is the relative path. And to do that, you have to specify dot slash and then the name of the script. You could hit tab, it will autocomplete. So now you hit enter and you'll see it ran. So keep that in mind. There are two ways you could run the script, one through absolute path and one through the relative path. If you are, let's say, in slash home directory, and now you want to run the script, you could still specify the entire path, starting home, starting my user directory, or you could just simply start from the directory you are in. So you are in IMf from this home onward, IMf scripts and the script name, and hit enter, and you see it works here too, because you you have to let the operating system know where your script exactly is located. So that's a basic about the scripting, how you run it. So please remember these two main points about running the script. Okay, now we know a lot about what are the different type of shells. Now, how do we start a shell? How do we get into a different shells? Well, it's simple as is. Simply type the shell name. Meaning, if you are in Bourne shell and you want to get into just shell or C shell, just type SH or just type C shell. So, without explaining you more in detail, I'll log in straight to my Linux machine and I'll show you how you could switch from one shell to another. Okay, so I have this Linux machine, and you notice that I have this GUI running in Linux. Inside the GUI, I have this terminal. So all the commands that I run from the terminal is actually a, a shell. And that shell is, how do you find a shell? You do echo $0, and it tells you my shell is bash. Now, if I don't want it to use this command line, and you see in the back, I have this directory called home, and I have this trash can. So if I wanted to view the contents of home, what I do, I double click. So this environment right here, as you see, this environment is genome environment. And remember I told you genome is also a type of shell. So this is another shell right here, and this is command line inside is another shell. So if I wanted to open this folder, I am telling genome, which is the desktop GUI, to open up that folder. So double click and it will open up the contents of that directory, and these are all the directories I have. This is the file I have of all the directory. If I want to go into another directory, another file, or if I wanted to open up this file, I'll double click, and the genome shell is interacting with the kernel and operating system and telling it to open it up. Now, what if I do not have this GUI environment, right? So, and not everyone is a Windows, um, not everyone wanted to get into Windows, they wanted to get in the command line. So what do they do? So if you wanted to view the content of my home directory, I'm sure you know the output. I'm sure you know the output of PWD, which means home I have solved. So now if I wanted to view the content of my directory, I do ls minus l. And you see here is a list of all the directories that I have in my home directory. So I did the same thing as I was doing here by double clicking it, but right now I use the command ls. So when I use the command ls, I actually am telling my bash shell to do this ls command for me. So let's do clear, and it will clear up my terminal. Now, if you wanted to see what other shell that you could change to, you could just simply type sh. When you hit sh, you see your shell prompt changes. And you could also verify it by running echo $0, and you'll see it is shell. Now, if you wanted to exit out of this shell to go back to your bash, you type exit. And if you want to go to, let's say, C shell, so you just type C shell. And you are in C shell. To confirm you are in C shell, you do echo $0 with C shell. You want to get out? What do you get? How do? You do exit. So that's how you get out. Now, what other shells that we learned? Let's say if you wanted to start a corn shell, SKSH. Hit enter, It says bash corn shell command not found. It's a similar command as you could use, which is C shell. No, I want to use corn shell. Why I cannot get into corn shell? Maybe because I do not have corn shell installed in my computer. And how do I verify it? Simply do cat shells. Okay, tell me, do you see corn shell in there? No, right? That's why I was not able to start that corn uh, shell actually. So anyway, so that's how you could switch around shells, start a new shell. Again, this is if you want to get into a different shell environment. Now, how does it relate to shell scripting? The shell scripting that you want to learn, right? That's what you're probably thinking. Well, if you are creating a shell script, let's say in corn shell, and as you see right here, I don't have corn shell. That script is not gonna run. So you need to know your environment beforehand before you spend tons of number of hours and then realize, oh boy, I don't even have a corn shell, and you're not even allowed to install or download a corn shell. Anyway, so that's about changing the shells. One of the basic things that we should know is how to run a shell script. So when you create it, there are different ways you could run it. You could run it through absolute path, or there's another one that's called relative path. So absolute path is if, let's suppose, if you are standing right at the first step of a stairs and you have to pick up something on the very last tier on the top, you have to actually either shoot from the first tier all the way to the last tier on top and grab that thing that you're trying to grab, or there's another one, another way is relative path. The relative path is that you actually walk up to the stair and then grab that thing that you wanted to grab. It's the same way um, absolute path and relative path works. If you do not know what exactly absolute path and relative paths are, I would recommend you that you should, try to look it up online and see what they are and how they work, and you'll find a tons of article there, and make sure you type absolute path in Linux or absolute path in relative path in Linux as well. So the way it works is I have my Linux machine up. Let me log into my Linux machine. So I have my script right here. It's called XYZ dash script. If you notice, I am in my slash home slash ifzol and slash script directory. I created a directory called scripts in my home directory, and I create all my scripts in that directory. So if I am already in that directory, I could run that script. Or if I'm not in my directory, let's say if I just do cd, and which directory I'm in slash root. So the script that I want to run, it's just a test script that I created earlier. Let's say if you type that script name xyz dash script, and when you hit enter, you'll see it says bash the script name command not found. Why? Because the Linux operating system is trying to find that script in slash root directory, and I do not have that script in slash root directory. So I would have to specify the absolute path to run the script, and the absolute path would be just the same way as if you are standing at the bottom of the stairs and then you have to fetch something from the top of the stairs. Then you actually, through some kind of means or like a stick or something, then you could grab it. So the same way you could specify the entire path, which is slash home, my user directory, scripts, and now the name of the script. Now when I run the script, I'll hit enter and you will see it's just a script that is actually echo out or print hello world on the screen. How does this script create it? I will cover that in later lectures, but just to focus, this is how you need to run a script using absolute path. Now, what if you are in a relative path, which is that you are already in home, IFSol, and scripts directory? See, you cd into that directory, you do pwd, and you'll see the path is the complete path now. Now, the script name is, again, when you do ls-ltr, I have that script, xyz script. Now, when you run the script now, script, and hit enter, it still cannot find it. Why? Because when you are inside of a directory, you will always have to specify that you want to run the script within this same directory, and that is the relative path. And to do that, you have to specify dot slash and then the name of the script. You could hit tab, it will autocomplete. So now you hit enter and you'll see it ran. So keep that in mind. There are two ways you could run the script, one through absolute path and one through the relative path. If you are, let's say, in slash home directory, and now you want to run the script, you could still specify the entire path, starting home, starting my user directory, or you could just simply start from the directory you are in. So you are in IFSol from this home onward, IFSol, scripts, and the script name, and hit enter, and you see it works here too. Because you you have to let the operating system know where your script exactly is located. So that's a basic about the scripting, how you run it. So please remember these two main points about running the script. Script format. Having a proper format inside of a script is very important. Why is that? Because I'm gonna bring back the same analogy. You create a script, it's a very long script, and a few months pass by, and now you need to modify the script or troubleshoot something in the script. You have written, sorry, you have written down the script, but it's all over the place. The variables is up, your comments are nowhere to be found, the description is nowhere, the commands are left and right, there's no indentation, nothing. So there should be a proper format that should be followed so that someone can come in and take a look at your script and says, wow, that's a great job. Whoever did that, so easy to read and so easy to understand. And what are those format? One is first and foremost is define shell. This is something that you have to define. You could say it as a part of format or mandatory. You have to do that. You have to define a shell. When you create a first script, you have to let your operating system know, run that script as bash script. If you're doing a corn shell, you'll have to specify pound hash slash bin slash corn shell. Anyway, when we write our first script, we'll cover that as well. Then comments. Right after defining the shell, you have to put the comments, and those comments always starts with pound sign. And the reason I am telling you that you should include comments is because comments should tell what your script does. When your script was written, who it was written by, was it there any modification, anything that you wanted to include that a user or someone else reading your script can understand what this script is about, please add that to your comments. Then define variables. Variables, what those variables are, we'll cover that. Not to worry about it, but just to let you know quickly, the variables is just like an alias. If you have a long command or if you have a bunch of emails, what people do is they give it a letter equals the whole big command that becomes their variable. So define your variable at the top after comments. Then you run the commands. Whatever the commands that you want your script to execute, you need to specify those commands. Or if you do not have commands, or if you have any statement scripts, that's where you put your statement scripts. Those statement scripts are if, then, while, for loop, or so on. Now, when you have statements defined, you should start if, the line where you're going to put an if, hit tab, because this way it will show that your if statement is starting from this point on. There is nothing that script will translate your tab into something else. You could use spaces, you could use tabs, anything that you want, but try to make your script formatted in a way that if someone or even you read it after a year, 2 years, you'll say, ah, this is what I did. It's so easy to read. So let me log into my Linux machine again, and I'll tell you exactly how you should format your script. Okay, this is my Linux machine. I'm already in my directory. Perfect. I created a script earlier, or a file earlier, called Apache script. I'm going to take that same script and I will format it the way I have just discussed it. So to do that, I have to now do a VI on that script. And I am sure you guys know how to use a VI. Some of you are familiar with Vim, which is probably an enhanced version of VI. I like to use a VI. It's kind of old school, but the good thing is that it's available in pretty much all the Unix or Linux flavors. So I could never learn something new and not utilize it on an older version, because I use VI in many systems like Solaris, AIX systems, and sometimes Vim is not available. So VI is something that you will find anywhere, whichever is the system you log in. So anyway, I'm going to use VI to edit this file, which will eventually become a script. So you hit enter. Now the first thing, as I said, you have to define a variable, which has been bash. So if you look at the back, you'll see the first thing is defining your shell. I want to run this script as bash script. Perfect. Now, the next thing, I said to add a comment. Okay, always add a comment. I usually add a comment is like purpose, testing, script, format, date. Put any date. Let's say August 20, 2020. Um, Modification. If you have done any modification to the script, put down the date of that modification. So 02 08. So last modification, of course, since you're creating it the first time, I'll put 20 again. Okay, then anything that you wanted to add, please go ahead do so. So if I just put in blah, 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 whatever, it's just a comment. It has no effect on your script. Okay, perfect. I understand, Imran, but how come the first line that you have is slash bin slash bash has a comment in front of it? Isn't that isn't it will be considered as a comment as well? Awesome question. Trust me, I had the same question. But let me tell you this. It's just how it is. Sometimes, it is how it is. So the Linux will understand this as actually a shell script. And it always starts with pound and hash. Why? I honestly don't know. If you really want to know why, you could ask someone else who really know inside out when they came up with the writing scripts, or you could, I'm sure, go online and find out why you have to define with hash. But anyway, put that in the back of your head. You have to remember this no matter what. Okay, so moving on. Then you define, next thing is variable. Variable is something like I want, every time I want to echo something, I just want to say a and then echo. So let's say in my case, I wanted to have single quote Imran Afzal. Or, and you know what? I will say, my name is Imran Afzal. This is how you define your variable. And then you could just do echo $a. Then it is going, when you say echo $a, by the way, this is just a scripting language I already started teaching you, but that's okay. You need to understand the format. So variable I have defined here that every time this command will run, it is going to call upon this variable. So why didn't I put that whole thing here? I can, of course. But what if you are working in an environment that requires a huge line and does huge things? Then it's better that you put those variables in there. Then, of course, then you put command, let's say you want to run a date, you want to run a command df minus age, or so on. Then the last one I included as statements. If you are including statements in your script, please do not start from if, let's say, dollar $a equal, um, let's say, file or whatever. Do not start like that. Always put tab like this. So if something is equal to that file, enter, and then tab again. Then echo this, else, echo that, and then fee to close the statement. You see how it is? That entire if statement came to be on the right hand side. So you know that this is the statements that I want to run, and they are indented to the right side. What are those statement scripts? I never seen that. Don't worry about it. I'm gonna cover that in my next lessons. The purpose of this lesson is just that you know that why would I follow this format on the following lessons. That's why I wanted to cover that right now so you would know. This is the best way to put your scripts together, and it would be so easier to remember when you come back to it. Hello world. Okay, yes, this is the basic script that most of the time that I've seen people write whenever they start learning scripting languages. So we are learning bash scripting languages, and the first script that we will write is to echo or to output on the screen that reads hello world. I remember when I was in college, the first script that was given to me by my teacher and or by my professor was to write a script that would output or print on the screen that would read hello world. So anyway, I am going to do the same thing for you guys, that I want you to create the first script. If you know this, how to create a script, awesome. But start with me. Let's go with me. So we're going to start with creating the first script that will output hello world. So I have already my Linux machine session open, and I am logged in as myself. Now, as a practice, as I mentioned before, that always create your script in a specific directory so it will be easier for you to remember where those scripts are. So let's do cd script. Have already created it. You should have that too if you follow my earlier lessons. If not, then go ahead, run the command make dir followed by the script, and it will create a script directory. In that script, if you do ls minus l, you're probably not going to have anything if you never had a script before here. If you do, then go ahead and delete the script. The first script that I'll delete is hello world. It says permission denied. Why is that? It is owned by me. It is owned by my group, and I could remove it by looking at this W. It has write permissions. Why can't I delete it? That's a good troubleshooting exercise as well, right? I know why I can't delete it. Because when I created the folder or directory called script, I was root. So let's go one step back, cd dot dot, do ls minus l, and you will see, yeah, I was right. See, right here it says this directory is created by root. So anything under this directory will be protected by user root. Nobody could touch it or delete it. So the best thing I should do is to become root, go into my home directory, and I will simply remove that directory now. So this will start fresh. Okay, so now it's gone. Let's exit out of that root. Make sure you are yourself. Yes, we are on logged in ourselves. Also, you could check by looking at the prompt, which tells you the name of the user logged in and the server name. So now we are in our home directory, and now we're going to create a directory called scripts. And we will put all our script from this point on to our folder called scripts. Now make sure it is there. Yes, it's there. It's the end, and now it is owned by me. Now you don't have to run all the scripts as root. The only time you would have to run scripts as root if the commands that you are adding inside of your scripts require root privileges. Yes, so you could run any command like pwdls or anything that do not require root permissions. If you are running other commands, let's say dmi decode or dmessage or df fdisk command, those are the type of commands that require root rights. So it's better that you run those commands, those scripts. You create those scripts as root. Anyway, so let's get into our scripts directory. And now you see we don't have any file or any directory in our scripts directory. So we will create our first script and we'll call it hello world. And you could put .bash as well, but since we will be working primarily with bash shell, so we don't have to specify the extension. So just simply hit enter. Once you are in the VI mode, you specify the shell. So we want to run this script as bash. Good. Second thing, who is the author of this script? I will say it's myself. Perfect. Then again, a comment, date, script is created. Let's pick any date. So let's say if you're picking 08 slash 20 slash 2020. Okay. Then we'll put in a little description, and that will read, this script will output hello world on the screen. That's it. Simply that. Now, if there are any modification, so you could put a date modified, and then you could put the date. Since we are doing the first time, you could just put it the same date as we put a date created. Okay, so our shell is defined, our comment is defined. Do we have to add anything? Nope, it's just a simple script. So I will go ahead and write the script that will print echo hello world, and that's it. Now you could just do escape out of it and write quit, and your script is created. Now verified, yes, the script is there, but you cannot run it. Why? Because it does not have executable permission right here. So in order to uh, assign proper executable permission, you will have to run the command change mod all plus executable hello world. And by the way, I'm using tab that auto completes the file. And if the file does not exist, it will not autocomplete. As an example, let's say if I, instead of HELLO, I'll put HALL and hit tab. See, it's not going to work. So it has to have a correct spelling. Okay, so we have modified the permissions. Let's verify it. Yes, now it has the executable permission. And as if you see, as soon as we gave it executable permission, its color changed as well. Now, please remember, don't focus on the color. As I said earlier as well, that sometime maybe you probably creating a script in Solaris or in AIX or in any other Unix or Linux flavor that does not give you that color changing scheme, or that depends on the environment, the shell. So that's why just focus on that it is executable by looking at the executable permission. Okay, now perfect. Now let's run it. So again, you could run it through the whole path, which is absolute path, script directory, and hello world, and hit enter. And there you go. Your first script is created. Isn't that fun? You have just created your first script, which outputs on the screen hello world. Now, what I'm going to do is I'm going to run the script as a relative path. So dot slash hello world. There you go. It does the same thing, but it executes it with a relative path. Now, if you notice, there are no lines in between on top and bottom, so I wanted to make it more clear, more neat look. So what I will do is I'll modify the script, hello world, hit enter, and now I'm gonna put one echo here and one echo here. So when I put these echoes inside, then it will actually generate an empty lines before hello world and after hello world. And date modified, again, I could just put it like, let's say if you're modifying it a day after the first time you create it, then you just put 21. Save the script, and now let's run it. Hello world. Nice. You see? Now it is giving the output that you want. Now, as an exercise, I would recommend you to go ahead and create a couple of scripts like that will output on the screen. Like my name is Imran Afzal. I love to teach, and I am whatever that you wanted to add. Just output on it. Chop the lines, whichever the way you want it. This will give you some practice on how to create simple scripts. In this lesson, we are going to define variable and run those variables. So this is a good exercise where you will learn how you could define variables at the beginning of the script. So anywhere you would need to use those variables, anywhere in the script middle or at the end, you could just simply run that container, that variable. So what exactly a variable is? So let's look at this. So look at this list that I have. Now you see I have defined a variable for P. I have put it PWD. For L is just simply ls. W is for who am I, D for date, and C for Cal 2018. So these are the variables. The variables are the first digits P, L, W, D, C. And the commands that variable, the commands that inside of those variables, I would say, are the ones on the right hand side. So this is how we're going to create our new script by having those variable defined at the beginning. So I'm going to log into my machine. I believe I already have logged in. So what I'm going to do just for fun, just for exercise, or just for practice, I'm going to go one step back, and I'm going to create a new directory called mkdir, and I'm going to call it my scripts. So it's just to tell you how you could differentiate from one directory to another. But anyway, whichever directory you pick, make sure there's specific directory for every script. Don't just put it in your home directory or anywhere else. It's not a good practice. So I have this directory created, my scripts, and I am going to create a new script. I'm going to call it, let's say, um, variable test. Just that. Okay. And the first thing what you have to do is bin bash, and then you have to define the comments, the author, the description, the date it was created, and all that stuff. I'm not gonna take a lot of your time to go into defining every single one of it. So I'm just gonna, from now on, I'm just gonna define the shell, which is the mandatory thing. So, and then I'm gonna go straight to um, running the script, writing the actual script. So anyway, because I do know the time is valuable for everybody, but I am very hopeful that you guys do follow the standard that I have. So first thing that is I'm gonna do is put a comment here. I'm gonna say define variables. Okay, and those variables are, first one is P equal PWD. Second one L and ls. W is for who am I, but you know what? Actually, there is a command called W in Linux, so I'm just gonna put um, who am I, just WIV. So that will be who am I, date for D, and C. Now, since the C is a calendar and that I want the 2018 calendar, so it has a space in the middle, so I have to put that in quote. Single quote should work. If it single quote doesn't work in your environment, you could put double quote. That's fine. Okay, so now your variable defines. Now, what you do is you could just simply say echo um, run variables tasks. Just that. Echo again. Now I'm gonna run the command. Sorry, I'm gonna run the variable p. To define the variable, to run it or to get executed, you have to start with $p. So this way, the operating system or the shell would know that you want to run that variable. Okay, perfect. Next variable I want to run is L. Third one is WI. Fourth one is D. And fifth one is C. So it's just that simple. Let's save it. Okay, now let's give it a proper permissions. Let's see, it's there. Yep. Let's verify one more time. Yep, you see, the reason I came in, I wanted to see if it has all the proper variables in. Okay, looks good to me, but let's try to run, because to test a script, always run it, variable, and test. Okay, so we do have some kind of error messages. Perfect, that is fine, because as we learned, we wanted to see where those error messages are and how can we troubleshoot. Now, as you see, the first message that is giving us that there is in line 8, it says unexpected end of file while looking for matching code or single code. So let's go to line 8 variable. And to go to line 8, it's just simply type line 8. And it's it. See what happened? I put single quote here and I put double quote here. Okay. All right. So one problem is fixed. Let's run it again. Okay. I think it ran fine this time. Hopefully. Yes. Okay. Run variable test. And those variables is pwd is this. The file is variable inside of the directory, the user who, which is a variable, date, and the calendar. So that's how it was coming up. And you notice when I ran the command earlier, the test variable, when it had a problem, it gave me error messages on 2 lines. Do you know why? Because first line is 8, which had that double quote on one side and single quote one side. So that we know that was error. But why we were getting um, error on line 17? Think of it. Let's check why we were. I know, but I want to show you exactly why. So let's go to the file and now this time type 17. Ah, you know why? I'm sure now you know why. Because in line 8, the defined variable was this, which had a problem. And in line 17, when it came down to run that variable, it says, hey, I can't run that variable. So that's why it gave us error messages in 2 lines. Okay, so anyway, so that's how you define variables. Going forward, I will be using scripts. I will be writing scripts in different directories. I could be writing in my script. I could be writing in just the script directory. But anyway, you could just follow just one directory if you want to, or you could just do different directory depending on how you want to structure your scripting skills and how you want to organize them. Do while scripts. Do while scripts are very similar to for loop scripts.
The do while script or statement continually executes a block of statements while a particular condition is true or met. For example, if you are running a script and you create it in a loop, it will run until a certain variable is met. For example, if you wanted to run the script until August 2015 at 2 p.m., then you will define that in do while script. And a lot of times the scripts or the daemons, the process that never dies, that keep running and running and running, they always have do while scripts because they are running continuously until a certain condition is met. So for example, run a script until 2 p.m. As soon as the 2 p.m. hits, you are done. Exit out. While condition, do command 1, command 2, command 3, and once all these commands are done and the condition is done, then you are done. You are done with your script. So let's look at our Linux machine and let's try out a do while script. Let's clear the screen where we are. We are in my script directory, which is this directory we want it to be in. And this time we're going to create a new script and we're going to call it script do while. Again, it's just the name I'm picking. You can pick anything you want. Hit enter. You are in VI mode. You hit insert and you start typing. What's the first thing that you type? You type hash bang bin bash, which defines your shell environment. And if you wanted to put a comment, you could say this script is created by Imran Afzal on 2018. Yeah, that's fine. And if you wanted to put a description of the script, you could do that. But let's get into the script. I have already written down a script and I'm just going to go in and copy it. There are two scripts in my handout. I'm going to take the second one. I want you to do the first one yourself. I'm just going to copy it and I'm going to paste it real quick. Let's see what the script does. The script is doing, of course, the first one is defining the shell, which we already have. So we're going to take it out by hitting DD. And then it's telling us that the count is 0, the number is 10, while the count is less than 10, do echo number of seconds left to stop this process. And the process is the variable, which is $1. And echo is just an empty space, empty line. Sleep is a command that will wait for the number of seconds that is defined after the sleep command. Then it has a few number of expressions. These are the expressions. You could get it anywhere online. I have that expression for a while that I tried out many times in my work environment. It works perfectly. And if you want to use it in your work environment, you are more than welcome to do. So the next one is the echo, and then it says echo $1 process is stopped, and echo again, it is telling it that it's giving an empty line. So let's run the script and let's see what it does. Give an executable permissions. It says 10 seconds left to stop this process. 9, 8, 7, 6, 5, 4, 3, 2, 1, and done. Process is stopped. You see that? So these do while scripts are created for a certain value or certain time to be met. And once that variable is met, it will stop the process and exit out of it. I want you to create a new script in your environment, and this is the script. Again, this is also in the handouts. You could copy and paste the script, create a new script and run it. You could also be my guest to go online and just type do while script examples. There are tons and tons of do while scripts that you could try and get a little exposure to do while scripts. I'm sure by the time you will run at least 5 or 6 scripts, you know exactly what this statement do. If then scripts. Now you know how to write scripts. Now let's get into one step up. Some advanced scripts, some if then scripts. These are the scripts which will define some variables, and if those variables are met, then you could run those scripts. In if then script statement, if this happens, do this. Otherwise, do that. So whatever that you define that has to be met, then it will run it. Otherwise, it'll give you some different output depending how you write a script. To better illustrate this concept of if-then script statements, let's get it into our machine. Okay, which directory we are in? We are in our home directory, and the directory inside of it is my scripts. In this directory, we're going to create a new script, and we're going to call it vi if then script. Again, it does not have to be the name that I'm picking. You could pick any name like my script or XYZ or ABC, anything that you want. So when we want to write a script, you do vi and the name of the file. It will get you into the insert mode. So the first thing you do if you want to write a script is define a variable. Now I already have a script written that I'm going to copy it from, so it will save us time. And this is the script which checks for the variable. I'm going to copy it and I'm going to paste it. Now let's look at what this script does. This script is gonna look for count equal 100. So if count equal 100, which is the variable, then it's gonna say echo the count is 100. If it is not equal to 100, then it's gonna say the count is not 100. So that's what pretty much if else statement does. So let's look at our script. Let's run it. Let's first save it. And once we save it, we'll of course verify the file is created. Yes, what's inside of the file, we'll look into it, and it has exactly the same thing that we typed in. Now we need to give executable permission to this script. Verify it. Yes, it does have executable permission, and I'm gonna run it. There you go. It says the count is 100. Perfect. Because we defined in our variable that the count is equal to 100. So what happens if we change the count to, let's say, 1? We save it and we run it. Once we run it, it says count is not 100. So this is the exact purpose of if then statements. Is if it looks for the variable, whatever the variable is defined, if the variable value is not met, it will tell you exactly what you want it to do. You could also change the output by saying if then else, saying sorry, the count, let's make it lowercase, count is not 100. Again, count is 100. This is our variable, and it says if bracket count equal 100, then echo it, count is 100. Else Otherwise, echo, sorry, the count is not 100. And fee is the opposite of if, and it is telling the script now you should exit out, that your work is done. An if else statement is done. So you exit out of it by saving it. And now when you run it, it tells you, sorry, the count is not 100. So you just change the output to whatever you want, and that's what the if statement, if else or if then statement does. Another example of if else statement that I'm gonna pick is right here. I'm gonna copy it and I'm gonna create a new script. Is if then new. I'm gonna define the variable which I already copied, and the first command I have clear. It means when the script runs, it's gonna clear the screen. I don't want to see anything that's already on the screen. Next thing it's gonna do is if minus e, which is used, which is the option that is used to check if a file exists or not. So it's saying if this file, home ifl arrow.txt file exists, then what you should do, you should then echo file exist. Else, if file does not exist, then say echo file does not exist. And that's what pretty much it's doing. So let's run this command. And we of course have to give executable permissions. Let's verify it has executable permission. Okay, it does. Now let's run it. If now new. Okay, when you run it, it says file does not exist. It's telling you the actual thing. Why? Because there is no file exist. Let's do cat if then, and it's the file exists. Where should the file exist? The file should exist in my home directory error.txt. So I'm gonna create a file now. I'm gonna just touch it and I'm gonna create this file. The file is created. Now I'm gonna run the script. And now it says file does exist. So this is sometimes a very useful command, and it is a very useful tool for system administrators who wanted to run this command at a certain intervals or a certain day, because an application creates some error files or not, and they run this script on cron job to see if the file exists or not. If it does, it means the application is running fine. If it does not, then it means the file does not exist, and it will throw you an error message. So this is a if then statement, and we do have other if else statements examples in this file as well. And this file is also part of your resources, your handouts, and I want you to try out every single script, create every new script, and try out different values that you have here. So this is a very cool script that I have written. It tells you about your name, and it's asking you, do you like working in IT? And it asks you, if you respond yes, it'll tell you you are cool. If it does not, you say you should try IT. It's just a good feel. So I want you to run the script on your own, create a new file, write the script, and execute it. And I'm very sure it will run just fine without any error.
Accessing data from a file. A file consists of some kind of data, right? It has a lot of information inside, and you need to pull that information every now and then. Now that file could be any file. That could be application file, database file, a simple text file, a log file, or any kind of file that you try to retrieve some data, massage the data, and you want to view it the way you want to. Now, you could do that manually by running commands, adding commands here and there every day. But of course, if you are doing that changing of data or running those commands every day, then this task, doing it manual, become tedious. So the best thing to do is to automate that. And the way you automate it, you actually create a shell script to do that. So in this lesson, we are going to create the first script that will pull errors, failures, or warnings, or any kind of information that you want to pull from a file. So most likely, we will be using like our log messaging file, which is a huge file which gets which, which actually logs all the error messages or warnings or failures or many other system-related messages in a file. But sometimes when you want to view that file, you don't want to go through all that stuff, that informational stuff, or something that is not related or is not actually what you're looking for. So this is the first script that we'll go into, and we'll create a script. The second script that I wanted to cover is when you actually have some of the administrative commands that you run, and then you want to change the output of the file and perhaps output to a different file. So this way, every time you come in, it's viewable by you, and whenever you run the command. So let's look at our first script. I'm going to log into my Linux machine through the PuTTY client. I'm logged in as myself, and I am in my home directory. Now I want you to copy uh, varlog messages from varlog to your current directory. Now, what is your current directory? Your current directory is home IFSol. Now, I want you to go ahead and create a new directory and call it um, professional scripts. This is the name you have chosen, where we will add all our newly created scripts into this directory. And when I do ls-ltr, you'll see at the bottom it has that directory. Now I wanted to copy var log messages file into my current directory, and that would be dot. When you hit enter, okay, you say it's coming up as permission denied. Why? Because var log messages file is owned by root, and it is not it does not have read permission for anyone else. So what we will do is we'll become root. And now I will copy var log messages. Sorry, I'm doing cd. Var log messages to my home directory. And from there, I will copy it to professional scripts. Now it is copied. Now let's go to my home IFSol professional scripts directory, and let's see, the file is there. Okay, good. So now in order for me to read that file, it should have the read permissions right here. So what I'll do is I will go ahead and first of all I'll change the ownership of the file, chmod IFSol messages, and well, okay, I think it's change mod messages file to IFSol. um, oh no, sorry, I'm using change mod. It has to be change ownership because we are changing the ownership. Okay, it is changed. Now you'll see, let me make this a little bigger. Now you will see this file, messages file, is owned by IFSol. Now I'm going to change the group as well. So change group IFSol to messages. And now you will see I should be able to read this file. So I could have assigned the read permissions right here with change mod, or I just have given the ownership. I changed the ownership to IFSol. So now I could exit out of root. Now which directory I'm in? I am in /home IFSol, and I'm going to go into my professional scripts directory, ls-ltr, and there it has the messages file. Now to make sure I could read it, I could just simply cat the messages file just to make sure I could read it. Yes, I could read that. Let's clear the screen. Now I'm going to create a first script. I'm going to call pull data. If you are using different scripting as well, I'll put .bash here, but I'll just leave pull data. Hit enter. Now what do you do first thing? You give the correct shell script. Sorry, the shell, which has been bash. Next, you put the author, date, 08 slash 08 slash 2020. Description. This script will pull only error messages from var log messages. You could directly pull those messages, but you have to be root. But since we are not root, it's just the example that I'm giving. We copied the messages file in our in our home directory and modified. If it is modified, since we are creating for the first time, we'll leave the same date. Okay, so our basic things are done. Shell is defined. The comments are defined. Now, what are exactly we doing? We wanted to pull only error messages from the messages file. We don't want to view anything. So to do that, we'll have to do grep because we are grepping for error messages. -I is to ignore lowercase or uppercase error. From where? I would always specify the absolute path. You don't want to specify the relative path because if you're running from another directory, the same script will fail. IMf&x professional scripts. So for now, just run that and just make sure if it works. So controls quit, right quick, enter. Now the next thing you have to do is give executable permission to pull data, ls-ltr, and you'll see our first script is created. So when I run that pull data, it says grep home IMf&x is a directory, because we did not specify the file. We need to go in one step inside. So pull data, and we are actually trying to grep for errors from directory. So of course there is no such thing as a directory doesn't have the data. Directory only has files. So we'll put messages here. Okay. Now when we run this script, it is giving us only the error messages, all the lines inside of that var log messaging file. I'm only getting the error messages. Now, you're probably thinking, why do I need just error messages? Well, if you are in corporate environment, trust me, you're gonna be troubleshooting system related, application related so many times that you would have to go into the log files and look for error messages that where it failed. So you could go through one line by line, which is going to take you forever, or you could just simply filter out for error messages and then you will get right to the point that why and how it is failing. Now there are some failed messages right here. Of course, we are not troubleshooting these failed messages, but it's just an example that I'm giving. Now, every time you come in, you log into your system, your manager or your someone from the development team or someone who say, hey, I'm getting error message from this system, or system is running slow, or this application is failing or something. So you just, all you have to do is run the script and see what are those error messages for. So what I will do at this point, I will, instead of do pull data, I will rename this file to move pull data to pull errors. So this way it is specific to the data or the words that we are trying to pull. So let's run again, pull errors. And now we have all the errors. Similarly, if we want to pull all the warning messages, we could do the same thing. But instead of recreating a new script, what I will do is I'll copy pull data, or sorry, pull errors, and I'll name it pull warning. So now I have two scripts. One is pull errors and the other one is pull warnings. But now both are same, so I have to go into the pull warn script, and I'll have to, instead of error, I'll put in warn. Okay, now save it. Now let's run pull warn now, and you will see we have a lot of warning signs in the system. What's going on? See right here is warning application, genome settings killed by signal 5, or any of the things that happen with your application or your system, it will be logged here. Now the last one I will do is, let's copy it again, pull warn. I will do pull fail. Okay, now I'll go into fail script again. Instead of warn, I'll just do fail. Now I have three scripts to verify it. There you go. The last one is pull fail. So let's run pull fail. And now it's only giving me failed related lines. Anything that has fail in the line, I will only get that. Now you could also leave it as is right now if you want to, but most of the time what people do is they output this to another file. So this way they could easily manipulate the text inside of that file instead of just going into the var log messages. So how that is done, you could just, let's go back to our first script, which is pull error. And here I will go grep -I error, and I will output to my home directory. And this is the directory. And now I will name the output of the script as output error. If you notice, I have two slashes here, so I'm gonna get rid of one. So now let's run it. Now this time when you run it, it is not going to show you all those error messages on the screen. Instead, it is going to push out all the messages that came with the word error. It's going to go into a file that we just specified. So let's run pull error. And you see you got your prompt back. So it doesn't mean it didn't run. It did run, but it has created a file that you wanted to create. There you go. See, output error. So now you could just simply cat out this output error file and read through it. The same way you could do it with fail, the same way you could do with warning if you want to. Now, also what happened is, which I will also cover later on, that many system administrators, what they do is they schedule this type of scripts in cron job. They tell the cron job, run this script at certain time of the day, and when you come in, all you have to do is view that file. That's one step further. Now, if you want to take it another step further, what it will do is it will not only run the script, it will also send the output of the script, which is the output-error file, through your email, through the send mail protocol, which is one of the best ways you could do that. When you come into your office in the morning, and the first thing you do, you open up your email and you say, hey, I got these emails and alerts that saying I had these type of error messages. So this is about creating or pulling data from files. You could also modify it in terms of if you wanted to just see the number of warnings, you could just do pull warning. So you see when you run it, you get all those messages. Now you could use your own script and combine it with operating system commands to view or to change the output of the script. So if you wanted to see how many warning messages or lines we have when we grep for warning, you could just do pipe wc minus l, and you'll see there are a total of 46 warning messages. This shows that since we have the system, we have 46 warning messages that came in. You could be more specific. So if you wanted to just do grep and code and you just wanted to do August 27th, then it will only pull August 27th warning messages. And how many we have for August 27th? We have 46. So basically, all those messages that have came in today. Anyway, so this is how you pull data. This is how you modify. The second script I wanted to go over is a script that will format the output of the administrative commands. Let's do the administrative commands. First, I'm going to create a new script called admin commands and hit enter. And I will go through again because this is something that you really need to know. Author, date, description of the script, format the output of admin commands. And the last one is modified. Please don't get annoyed by this because I'm keep typing that. The reason I do that is because I really want you to get in the habit of doing that. This shows that you are an organized engineer or administrator who actually organize his or her scripts and put all the scripts in the right way. So 2020. Okay, now what are other commands that we wanted to do? Let's do some administrative commands like date, uptime, and df minus h. So let's say if I wanted to do that, and let's say we run it. Before we run it, we have to give executable permissions. And now when we run it, you'll see I have the date right here, the uptime, and the df minus k. Now, when I mean to format the output, you could do that by either you run the script and format it in a way like, let's say, if you only wanted to view the first column of your script, then you will only see like Monday, the date of the uptime and file systems are. That's if you wanted to change the format um, after you run the script. Or you could go into the script. The script is vi admin commands, and you could go into date and you could do awk print $1. Uptime, you could do awk print dollar, let's say 3. And for the df minus h, we'll just grep for root. So this is how we change the output of the command. So now when we run it, you'll see the first column, it gave us Monday, the second column is the date, and the third is df minus h. I just wanted to know only the root partition, how much disk space I have, how much I have left. I don't care for other file system. So this is how you could make changes to it. Same way, there are so many commands that we learned earlier. If you wanted to change the admin commands and you wanted to format it, you could try it with different commands. And this is how basically we could access the data from a file. Okay, it's about time now we start for loop scripts for file system. Well, we already learned for loops earlier, but now we are actually going to learn more smaller and bigger and advanced for loops as well. I am going to actually include multiple scripts here. It's not, this lesson is not about just one script and we'll move on. In this lesson, we are going to create simple counting for loop scripts, how you could use it. There are counting by 1 to 100 or whichever the specified number of times. We are going to create multiple files with different names. So if you want to create, let's say, 10 files, are you going to do touch 1, touch 2, touch 3? No, right? You want to create a script that will create multiple files, and of course with multiple different names. So that's what we're going to cover. Next, we're going to cover create multiple files with user input. So user will have to specify, it will be like, hey, do you want to create a files? Yes, and what's the name of the file? There's how many files do you want to create? I want to create 10 files. Wouldn't be that nice? Then we have to create another script like assign write permissions to files. We'll create another script that will assign write permission to files with total time it will take. So I am actually going to cover 5 different scripts in this lesson. And the reason I'm keep on focusing on for loop is one of the important statement for loop scripts that you will be using more often than any other statement scripts. Okay, without further ado, let's log into our Linux machine. We have our Linux machine right here. I'm gonna clear the screen real quick. Um, I'm gonna exit out and I'm gonna log into my other one, which is right here. Clear the screen. Who am I? I have solved. This is my other session that was running. I don't want to have 2 different sessions open. This will do nothing but to confuse you more. Anyway, I am in my home directory and I want to go into my professional script directory that I created earlier. I have a few scripts that I worked on it earlier. You probably have it too if you're following me exactly every lesson one by one. Anyway, let's clear the screen out. The first thing I wanted to do is I wanted to create a simple counting for the for loop. So what it does, let's first create the script, then you will know exactly what I'm talking about. Simple count. Again, what do we have to do, guys? So now I am trying to save you time. So I'm just going to leave this author date so you could fill that up yourself. Description, but please don't forget to do that. I am skipping it because I don't want to waste any more time on this. I want to get into straight into scripting. All right, so everything is defined. So now for loop I is just a variable in curly braces 1 dot dot, let's say 20. Enter. Now what I'm saying is I want you to put all the counting from 1 to 20 into a variable called I. It's just that what I'm doing. So think of it, you have a can and you're putting 20 numbers from 1 to 20 in that can. So that can name is I. You could name it anything. The can name is A, or just even you could even name it can as CAN can. So you could do that. Now, what do you want to do now? So you already put those 20 numbers in a can. What do you want to do? Again, it's a perfect example. So do. First is echo $I. So it is actually going to echo whatever is inside of the container. So I am actually boxing 20 numbers in a box. And then once I did that, then I want to open the box and read those numbers. That's pretty much it. And then I don't want to read all of them in one shot. I want to read one number at a time. It will read one number at a time, but it will read it so fast that it will look like as if it's reading all in one shot. So in order for me to verify that it is reading one at a time, I'm going to put a command inside called sleep one. Sleep one, what it's gonna do is actually gonna read one letter, sleep for 1 second, then read the second, the third, the fourth, the fifth. So I don't want to waste your time. I'll just put here 10. So we will just run the script for 10 seconds. It will sleep for 10 seconds. Oops. And right here is done. So I hope you understand this. For I in put there's a container I put number 1 through 10. Then what you want to do once you have all the numbers in a box, then do read those numbers from for me, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. But I want you to sleep, like put a break in every number while you're reading it, and that break is for only for 1 second. Okay. Okay, sir, we will do that. Perfect. And what do you want to do once I'm done? Then you're done. Don't worry about it. Okay. All right, let's go into our script, modify the permissions, simple count. Oops, sorry. And as I mentioned earlier, that you could use numbering way to do the change mod, or this way. I prefer this way, so I use it that. Anyway, uh, the permissions are done. Now let's run it. There you go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Done. See, it's just that simple. Now, you're probably thinking, hey, Imran, what is the real life application for this type of script? Okay, perfect example. You probably, perfect question, sorry. You probably installed a lot of softwares in your machine, right? If you are using Windows, you install software, it goes through a wizard. If you're running a Linux script, then you're installing something, it goes through some kind of little wizard. But then you also notice it gives you some kind of progress bar, right? That is where those people, those developers, put those progress bar by putting these counting in there. It does the counting, it tells you, okay, approximately it's going to take this much time, and that's how it does. Counting 1, 2, 3, 4, 5. So that's what actually is. Um, why I have not put it in a real example, because I want you to go and find that out how you could put that in a regular everyday example. Now going to other scripts, the other four scripts that I have, I'll show you exactly where I could put in other examples as well, but not just in installation wizard, but in something else. Second script now we are doing is we are going to create multiple files. Right here it says create multiple files with different names. By the way, these scripts that I'm typing, of course, I do not remember all of them on top of my head. I actually have them written in a notepad and another computer that is right sitting next to me. So I am not like you can't say, "Oh, Imran is a genius. He remember every script on his head." I don't. I'm just like a regular person like you. So I have this notepad open on another computer, and I have that notepad attached to every lesson that you're gonna do. So once you're gonna play that lesson or this lesson, you will see an attachment .text file. I would like you to open that text file and then look at that text file and then create it, your script. Anyway, so let's create a second one, and I'm gonna create that for multiple files. So vi create multiple files with different names. It's too confusing. Create files. Simple as that. Enter. Oops, I didn't put the insert in. Alright, you know what goes here. So before I do that, the best way to do is, I just remember, I usually do that. So I'll copy simple count, which we created just before that, and I'm gonna name it a different one, create files. All right, so now vi, so this way it will have everything up there that we need. Just remove this part. Okay, now for I like I, so I keep picking on I. You could pick anything again. In curly braces 1 through 10. Okay, so now you know again, I'm putting 10 numbers in my box, right? So now you know that. Okay, now what do you want it to do? This time I want to create files, and the file name should start with Imran. Perfect. And it should end with $I. Nice. So you see what I'm doing? It is going to create 10 files, and every file will have the name Imran.1, Imran.2, Imran.3, and all the way to Imran.10. See how easy it has become to create multiple files? Probably you would have to create 1,000 files. Then creating it manually, it's not productive at all. So that's how we use for loop commands. Anyway, moving forward, so I'm going to create 10 files with the name Imran, and then I want you to be done. Since I copied from simple count, it should have the executable permission as well. So create files, hit enter. Boom, it actually threw an error message right away. Perfect. I want you to have that experience as well, because you will be troubleshooting error messages while you are creating scripts as well. So anyway, it says unexpected end of file. This is EOF while looking for matching backtick and code. And it's line 7. So what I would do is I'll go straight into the file, create files, and I'll go into line 7 by putting :7, and it's coming right here. You see it has this thing tick. I don't want that tick. That's why I was giving that problem. Now save. Now let's run it, create files. Bingo. It came back. When you have a command that comes back and give you a prompt back without throwing any error message, what it means? The script ran successfully. Now let's verify if it ran. Let's do ls-ltr, and you'll see right here it created 10 files. Awesome. Perfect. Okay. Now let's move on to the next script. And next script, I'll just do copy, create files, and this time I'll do create files with input. Input, sorry, input. It stands for IP. I don't want to do this. So I will do in, out, in, out. vi create. You know what? I will change it. I don't want to confuse myself. In, out, instead of that, I will do user input, input. Now create files dash user input. What I'm going to do here is first bash, and let's get rid of all of that. And now I want the user to tell me how many files they want. So this is the third script. It says right here, create multiple files with user input. So user, the script will ask users, how many files do you want to create? And it will say how many, what's the name of the file that you want to create. So let's do that. Echo, how many files do you want? And I want the script to read that response, and that is T for total. It's just that I picked echo just to put a empty line. Then I want to throw another question at the user, and I'm going to say, please enter the start name of the files. So the file name, if you want the file names to start with Imran, then please enter Imran. Read n, just a number, not number, just a variable. Now, for I n, again, I is a variable. Now I want to put sequence here. So I put dollar sequence 1 through T. Okay, so this is going to, what it's going to do is, this is going to put this variable, which is the sequence, inside the variable I. And the sequence is going to be the number of files. So the reason I'm putting sequence here, not 1 through, let's say, $T, you're probably thinking, hey, Imran, why didn't you pick, let's say, dot dot, like this? This is something, if you have think of that, then I would say you are right on the right track. But in when you have to specify the variable, which is $T, then you cannot use one dot dot and the variable, because one dot dot only works with the number or integer. So in order for it to work, you have to put a new thing called sequence 1 through that variable which is specified by the user. It's just, that's how it is. That's what some people says. It is what it is. Okay. Now that is done. Do what? Come on, my cursor is stuck, looks like. Oops. My network went down. I don't know why, but anyway, I am going to copy this so I don't lose my work. I'll go into my machine. I'll verify the IP, and you see the IP is gone. I don't know what happened, but anyway, I'll just restart my network. This is just a command to restart. Um, you could just fast forward it if you don't want to know. I'll just log back into my putty session once the session comes back up. Now it has restarted. Now let's see if I got an IP. Yes, I got an IP. So now I'm just gonna do right here, restart session. It has restarted. Okay, so now I'm gonna go back into my PS directory and my script that I was working on. It says found a swap file name this, because I lost my session and it still has that .swap file open. So it says read only, edit anyway, recover, quit, and abort. I'll say recover and enter. Yes, it has recovered. So let me just quickly save it and make sure it does save it. Edit anyway. So now that's where we left off. Now we're going to do is do touch n, sorry, touch n, which is the name of the file, dot $I, which is the number that's specified by the user. Done. That's pretty much it. Let's save it. Let's cat. It is there. Now let's run it. Create files, user IP. Now it's asking me the question, how many files do you want? I want just 5 files. Please enter the start name of the files. This time I'll just put IMR, just first 3 initial of my name, because I already have other files in there. So I'll enter. And when you do ls-ltr, you'll see it created files with my name, IMR initials, and the 5 files. That's how you give that option to the users. If the users are not very friendly with the command line, then you could create a script for them and they'll run it and it'll create the script for you. Next, moving on, the another script that I want to do is to assign write permission to the files. So now you notice that I have created these files and I want to give, let's say, write permission to every one of them. So of course you could do that chmoda write and just do imran and then hit this asterisk and it will assign it. But what if you have different names, then you have to do one by one, or you could actually make a mistake while you're working on it. So it's better you create a script. To create a script, I'll name it assign permission. Oh, I don't want to do that. Again, I would have to write it, so I'll just create files and assign permission. Save time, assign permissions. Okay, so now for I in Imran, do echo assigning write permissions to $I, which to do is execute this to $I and sleep one, so it will do one at a time and done. Okay, so basically what it's going to do is going to look for all the files that has imran dot asterisk, and then it's going to do echo assigning write permission to all those files, and then it's going to actually assign those permission one by one. Let's run it. Assigning write permission to Imran 1, Imran 10, Imran 2, 3, 4. How many we have? We have 10, right? That's the one we created in our previous script. So let's verify it. Yes, there you go. So it assigned all the right permissions. Did it be give write or executable? We give executable. But anyway, you understand what I'm trying to do, right? So you could do, instead of X, you could just put W. Anyway, moving on to our last script for loop. I want you to keep doing for loops so you'll get used to it. The next one, I want to assign write permissions to files with the total time it will take. So if it's gonna take 10 seconds, then I want to know the wizard to tell me, hey, it's gonna take that much time. So I'm gonna use the same script. This time I'm gonna just VI the assign permission script. I'll come back right here, and this time I'll put right here ls minus l. Oh no, you know what? Total. Let's assign a variable. When you assign a variable, you hit equal and then tick, which is right above the tab. And the variable starts with ls minus l, imran, asterisk, and then how many files we have? Tick. This is going to give us the total number of files that starts with imran. Okay, so now echo. It will take total seconds to assign permissions. And the rest I'm going to leave out as is. I'm not changing anything. So, but this time I'm just going to update this one. Okay. All I did is I am telling the user that when you run this script, the script will take this much time to complete. It's just like as if you are installing a software and the software tells you that it will take that much time to finish the installation. And I am creating a variable, and inside the variable I'm putting this command. And that command is going to do is it's going to run ls minus l imran asterisk wc minus l. So what exactly that does? So this command, when you do ls minus l and when you run it, it will give you the total number of files that matches imran dot asterisk. So basically I'm saying, since we have sleep here, so if there are 10 files and it's going to sleep 10 times, then it's going to take 10 seconds. So let's do assign permission. See, it says right here, it will take 10 seconds to assign permissions because there are 10 files. Okay, So now let's check the right permission, and you see every file that has Imran has the right permission now. So these are a few examples of creating these for loop scripts. Try them again and again, and you will become very, very skilled in for loop if you try all of these scripts. User account management. This is the lesson we are going to cover how we could automate the user account creation. Now, why do we need to create user account and why do we have to have an automation around it when we all we have to do is to run a user add command, right? Well, that's a very good question. But what happened is sometimes you are working in an environment where your system is also being accessed by other users, let's say QA or development. And they also need to create user account for their own group, but they don't have root privileges. Or that's one reason that you need to automate the user account creation that you don't want them to run user add command and make a mistake or mess up your etc password file or even delete users accidentally, so you don't want to give them root access. So what do is you create an automation tool which will allow them to only enter the user's username and some information, and it will create that account for you. You could actually create sudo rights for them, and that's how they could do it. That's one of the reason that mostly people do, and that's one of the reason I created that script in the past as well, where I was working in an environment. There's IT group was huge, but they were all interlinked, where there was a QA department, development department, and database group, networking group, all needed access to the user accounts in Linux. So we didn't want to give them the full access, so we created this automation tool. Well, another way is that even if you do not have that type of environment, you are the only one, you want to create users, you could create them, but then again, you could do user add command. You would have to remember it again. What was the option chosen, whether that user ID exists or not. But anyway, this is what this whole lesson is about. What are we going to cover in this lesson is that first thing is we will create a script that will simply create a user account by just asking um, what is the username, and the user account is created and done. Second script that I will create is it will error out if the user already exists. Let's say if you are creating an account, let's say Jerry, and if a Jerry account already exists, it will error out and it will tell you, hey, this account already exists. Second thing that I want to add as a third script is add a user description. Now, you could use user add minus C option to provide that description, but most of the time people do forget to input that description or use that minus C option. So we could add that to the script as well. The fourth script that we will write, we will combine everything, but also add the user with ID option, meaning if you want to create a user with some specific user ID, it will ask you to put that user ID in and will create it. So what happened is Linux system, when you do user add command followed by the user, it will auto generate a user ID based on the SC password, and it will add one to the last created user ID, and it will give that user ID to the account. But sometimes there are applications that require a specific user account. So for that purpose, you have to specify user ID. And then the last script that I will create, fifth script with you, is adding everything that we discussed, all four scripts. But with that, we will also error out if that user ID exists. It will do the check. So this is a whole combined script. It's a little longer script, so we'll cover that one script at a time. So again, I have my machine right here, my Linux machine, and to um, save time, save my time, save your time. Well, your time is more valuable. So I have created through 5 scripts already. And if you notice, I have these 5 scripts: create user 1, create user 2, 3, 4, and 5. I will go over each script one at a time, but you have to write those scripts. Again, those scripts are in the text document attached to this lesson. You could download that notepad and you could view that text file and then simply copy paste or type it. I would prefer that you type it. Most of the time when you copy paste, something goes wrong with the script and it doesn't work. So type it. Anyway, so let's look at our first script. Vi create user 1. All right. Variable author date description. This script will create a user account, modify date. I already have that. Again, no waste of time. Next thing is echo, please provide a username. This is simply, it's asking your user to provide the username, and it's going to read the input and echo just line, and then simply it's going to run the command user add with the variable, and variable we have you, and the variable is the one that's provided by the user. And then once that account is created, it's going to say echo user account has been created. Simple, right? Straightforward. Yes, so let's run it. Create user 1. Please provide a username. I will pick Jerry. Hit enter. Jerry account has been created. Perfect. My script ran. Awesome. Verified grep Jerry from password file. And you'll see it created the Jerry account with user ID, group ID, home directory, and my shell. That's the first script. Second is I wanted to create a script that will ask the same thing, but it will error out the user that, hey, this user already exists, so I can't create a user ID for that. So for for that script, I have created a second script called, let's clear it. Vi create user 2. Hit enter. Same thing again with a little modified description. Please provide user ID, sorry, username, read you, echo. Right here, grep command. That's where I'm adding that check. It will check if that user exists or not. How it's gonna check? Right here. First, it's gonna run the command grep with -q option. Q is the silent mode. Don't show anything on the screen. And grep the user, which is that container which just user specified, from etc password. Okay, good. Now I'm saying if the error code is equal to, sorry, the exit status is equal to 0, meaning if it does find it, right? So if my command is successful, it will give me 0, right? And the only way it could be successful if it actually returns something. So if it is 0, then echo error. User, this variable already exists. Echo, please choose another username. Echo exit 0, just exit out. Don't do anything. Fee. If that is not equal to 0, if it's something else, then it will add the user. Then we'll go through it. If this goes through, if this checks is work, perfect, then error out. Otherwise, you run this command. User add, echo user account has been created. Let's run it. Create user 2. Please provide username. We created a username earlier, Jerry, right? We'll create it again. And it says, error, user Jerry already exists. Please choose another username. That's what we wanted to do. If I run the same command again, and this time I pick another user, let's say Kramer, and it says Kramer account has been created, you could check that, and you'll see right here, Kramer with user ID and um, from 1003 to 1004, it added one number to it. Okay, so this is the second script. Third script we wanted to do is add user description. Right here, the third one, add user description. So the way you could add user description is by running the command user add and the username, whatever, and -c is the option, and then you put in the code um, um, system admin guy or whatever, and then you run it. But most of the time people don't use that, but we want to force that user to add that user description. So I created a script, vi create user3. Updated the description, same thing, please provide username. It will do the check. Same thing if the user exists. It will come down right here. Next one, echo, please provide user description. Read D as in variable. And then right here it says user add the variable u -c option for description and the D, the description. The reason I put a quote around D variable is because you could actually add user description with spaces. So if you have spaces, then you have to have a quote around it. All right, time to run it. Create user3. Please provide username. This time let's pick Kramer. It's not gonna work because Kramer already exists. Run it a new one. Please provide username. So this time we'll pick George. Hit enter. Please provide user description. George, a character. Hit enter. George account has been created. Perfect. This is what we wanted. Now let's confirm. Okay, see it has a username, the updated user ID, and the description right here. User description is George, a character. Goes to home directory and the bash. This is our um, third script, which is to add user description. Fourth script is to add a user ID. Now, what if you don't want the Linux to pick a user ID for you? You want to specify that user ID. Perfect. Clear the screen. For that, I have already created an script, which is create user 4. Hit enter. Updated the description. Now here, same thing, echo please provide username. Everything is the same to check if the user account exists. Right here, echo please provide user description. And now from here, this point on, this is the new stuff that we have added. This is going to ask the user echo, do you want to specify a user ID? Because we also want to give the user the option to say yes or no. Or we could just simply force the user to say, hey, please enter user ID. But what if the user doesn't want to add it? They want the Linux to pick it itself. So that's why we have given the user both options, either specify yes or no. So we're going to say echo, do you want to specify user ID? Y/n. Read, and this is the variable I just picked, y and u. Echo. Now here we're saying if the variable equal y. Why I pick equal sign? Because this is what works with letters. If I had digit or integer there, I would pick -eq. But since it's a letter, I'm picking equal y. So what I'm saying is if the user enters y, then echo please enter user ID. Right? Perfect. And then once the user ID is entered, put that in a variable and name that variable UID. Okay. And then what to do? And then simply user ID has been specified. Then you run the command user add with -u, -c with the description, and -u is the option to add user ID, and user ID is the one that's been specified by the user in this question. Perfect. Echo user account has been created. Perfect. Now, what if the user says no? If the user picked no, I don't want it to pick a user ID, then what do? Then you come down here and then you say elif. The, the statement that you have to use is elif. Remember we had if then else? Well, else does is else uh, if you say yes, then do this. Else do whatever that you specify. But now since we have to specifically say n as the letter n, so that's why we have to pick elif. Elif user input is right here no, which is n. Then what you do is echo, no worries, we will assign a user ID. It's just a friendly message I picked. Then what you do is user add with -u -c for the description and the description that's been specified right here in this variable. And then echo user account has been created, fee done. And this fee is coming from this if. You always have to end if with fee. That's pretty much it, guys, for the fourth script. Save it, and now let's run it. Create user account 4. Please provide username. Kramer. Kramer already exists. Okay, no problem. I'll pick another one. Please provide username. George. Uh-oh. I created George already. Sorry. Okay. But it's a good check, right? Okay. Please provide username. Elaine. Hit enter. Perfect. Please provide user description. Elaine. Jerry. Friend. Perfect. Hit enter. Now it's going to get into user ID. Do you want to specify a user ID? This time I will say yes. Then it's going to say, now since you hit Y, now please enter the user ID. I will say 1007. I hope it's not picked. Hit enter. Elaine account has been created. Perfect. Yay. Let's confirm. Etsy Elaine. Yes. With the description, with the user ID. Perfect. Awesome. Okay, now everything is working as expected. Last thing we wanted to do is what if I had picked a user ID that's been assigned to, let's say, Jerry, which is 1003. It would have been a problem, right? Yes, but before we put that fourth script, let's run that script again, and this time we'll pick no, just to make sure our no works as well, right? You wanted to test both options. Create user 4. Please provide username. So I picked already all 4 characters. Moving on to the next one. How about we pick what's the characters of Seinfeld show? This is where I'm picking those user characters. How about um David? You guys know David Putty probably if you watch Seinfeld show. That's a David Putty, Elaine's boyfriend. So you'll pick just David. Enter. Please provide user description. I will put Elaine boyfriend. Do you want to specify user ID? I would say no this time. It says no worries, we will assign a user ID. This is what we wanted to do, right? David account has been created. Okay, let's see what ID it has been assigned. Ah, it's assigned 8. Okay, hey, why didn't it assign anything after Jerry? Or you know what, let's do cat password, and you notice it has 3, 1003, 1004, 5, 6 is not taken. 7, 8. Why didn't it assign 6? Well, this is by default, but Linux always picks the ID from the last ID. So if it's last ID, let's say even if I change it to 10, it will pick the next one is 11. That's a counting mechanism it has, so that's how it picked. Anyway, let's go back to our script. Let's not talk about how it creates user accounts. Now the last one. And the last one is the longest one is that we wanted to do everything that we just did. Let's clear the screen. But this time we wanted to do is last one, error out if user ID exists. Okay, so we do everything, but this time if the user ID is picked that is already in that C file, I wanted to error out. No problem. Let's see how we could add that in there. So I have created a script for it, create user 5. Everything the same, description is a little modified, same thing, please provide username, checking the username exists. Okay, next one is please provide user description. Then echo, do you want to specify user ID? This is what we did in the last script. Perfect, everything is perfect. Now, right here, if you notice, this is the part that I added. So if you are creating this script, I would recommend you to copy your create user 4 script and paste it as a newer one and name it create 5, and then you can modify by coming directly into this line where it says read user ID. Then you add these lines here. All right, so what this line is going to do, again, it's going to do the same thing, grep q user ID from password. Remember the same way we did if you go back up to check the user ID right here, it did the same thing, right? It grepped from Etsy password. So the same mechanism or same syntax of the scripts will implement right here. So we'll do grep q, which is silent, user ID, which is specified by the user right here from Etsy password. And if the status, um, the exit status is 0, then, meaning if it finds it, then echo error user ID already exists. Echo empty line exit. Exit 0 meaning completely exit the entire script. Okay, if it does not exist, then run user add with minus u option, sorry, not minus u option, with minus u variable, minus c as a description, d as the description variable, minus u and the user ID. Okay, and then echo user account has already been created. This is the check right here. If that check passed, it will create that. Now this one next coming down here is the same thing that we have. If the user says no, then you simply come to this one and run it. Okay, so let's run the script real quick. And 5, and this time I'm gonna pick um, um, Stella. Please provide user's description. Stella is mother. She's mother of George anyway. Do you want to specify user ID? Yes. And enter user ID 006. I know sorry, 007. I know user 007 ID has been taken. So I'm going to put it in just to test. And it says error user ID already taken, right? So I know the user ID 6 is not taken. So I'm going to put that in this time. Stella is mother. Yes. 1006. And Stella account has been created. Perfect. Grep for Stella. Etsy password. And you will see it has been assigned user ID 6. And when you do cat Etsy password, and you'll see it's at the bottom. Next time you create an account, it will automatically checks for ID and appends to a new one. But if a new one is already taken, it will give you, if it automatically goes to the next one. Anyway, this is about this user account management. I hope you have learned a lot from this lesson. It's a very useful script. Try it out with different options and a different way that you wanted to add a user account. If you want to learn more about Linux, check out my best-selling course on Linux at udemy.com, or you could go straight to my website utclsolutions.com and you will find the exact same course there.